Hi, boys and girls. So today I'm going to do a little review for the Lesson 23 Comprehension Check. Okay, I just wanted you to keep in mind that during this unit, we've been multiplying fractions by whole numbers, right? We've been looking at using repeated addition or multiplication, and we've been using models like an area model and jumping on a number line, okay? So I'm going to review some problems that are very similar to the ones that you're going to see on your comprehension check, okay? So you can pay attention however you like to. If you'd like to take notes, you may do that, or you can just listen. But remember, don't tune me out because this is really important, okay? So you're going to see one that looks like this. It says, which statement correctly compares 5 times 2/3 and 10 times 1/3, okay? Now, it shows a visual here, which I could use to determine which answers are correct, but I always like to be really sure, guys, so I'm going to solve these problems mathematically too. So if I were you and I were taking my comprehension check, I would write this down on a whiteboard or a piece of paper. So I'm going to solve them out. I have 5 times 2/3. So I'm going to multiply my whole number times my numerator. 5 times 2 is 10. And my denominator is going to stay the same. It's a 3. Okay? Next one, 10 times 1 is 10. My denominator remains the same. It's going to stay a 3. Okay, so now that I've solved these out mathematically, I know that they both have the same solution, right? And I can actually see that in this visual as well. So let's take a look at our options. It says both expressions have a product of 10/3. Is that true? Yes. Both expressions have a product of 1/30. No. I know 10/3 is not the same thing as 1/30. And when I look at my visual here, there is not 1 out of 30 shaded. So that's a no. The product of 5 times 2/3 is greater than the product of 10 times 1/3. No, because I figured out they're the same. The product of 10 times 1/3 is greater than the product of 5 times 2/3. No, because they're the same. Okay? So when you see a problem like this, I would recommend you solve them out mathematically so you know your answer is for sure. Okay? Another one. You're going to see the old drag and drop problem. Okay? So this says, what whole number goes in the box to show an expression that has the same product as 4 times 5/6? Okay, so I like to be really sure of these things, so I'm just going to solve that problem first so I know what I'm looking for. Okay, so 4 times 5 is 20, and I'm going to keep that over 6. So it's asking which of these could be the whole number that's going to be what times 1/6, okay? So let's see here. It says drag and drop the equation into each box to match the number line model. You won't use all your choices. So we're going to see which ones of these represent, okay? Sorry. So first off, we know we can figure out the whole number by seeing how many hops there are, right? So this has 1, 2, 3, 4, 5, 6 hops. Okay, so my whole number is going to be a 6. Then I need to see what are they jumping up by. That's easy to determine because you just are going to look at the very first hop. So they're jumping up by 1/2. So that means that they're doing 6 times 1/2. Let me see if there's an option down here. 6 times 1/2. Okay, so this one says 6 times 1/2 is 3/2. If I look at my answer, it's supposed to be 3, so it's not that one. 6 times 1/2 is 3. That would be correct. So you would drag and drop 6 times 1/2 equals 3. Okay, here I'm going to see how many hops do I have? 1, 2, 3, 4. So I have 4 hops. And what are they jumping up by? So they're jumping up by 3/4, right? Because each hop has 3/4. So I think it's going to be 4 times 3/4, and I'm going to see what it's supposed to equal. It goes up to 3 here. Okay, so what one says 4 times 3/4 equals 3? It's going to be right here. 4 times 3/4 equals 3. Okay? Oh, I see what I did there. So that was for this problem. Now I put another problem up here. I forgot that I put it on the same page because I was like, wait a second, that doesn't make any sense. So that's the hopping problem, right? You figure out the whole number by the number of hops, and then the fraction's going to be what they jump up by. Okay? Another type of problem you're going to see is one that makes you find the same product. So we already figured out that 4 times 5/6 is equal to 26, right? So now I need to think, what times 1/6 equals 26? Well, I know that the whole number times the numerator is how we get this numerator, right? So what times 1 is going to give me 20? 20 times 1 is 20, right? So for this problem, you would type 20 into the box. Okay, I hope I didn't get too confusing there. This is one problem, and this is another. Okay? Next. You're going to see one like this. The model below represents the product of a whole number and a fraction. Which expressions have the same product as what is shown in the model? All right, so I always like to figure out what product I'm looking for first before I start going in and guessing. Okay, so I'm just going to check that. Right here, I see that my denominator is going to be 3, right? Because I have 3 equal parts here, and 2 of them are shaded in each. So I'm going to have something over 3, and I'm going to go ahead and count 2, 4, 6, 8, 10. Okay, so this represents 10/3. So I know that these answers are supposed to be equal to 10/3. So I'm going to try them all out. So I'm going to multiply the whole number times the numerator. 5 times 2 is 10, and I keep my denominator, which is 5. Is 10/5 the same as 10/3? No, wrong. Okay, 3 times 1 is 3. My denominator stays the same as 5. That equals 3/5. Nope. Wrong. 3 times 2 is 6. My denominator stays the same at 5. 6/5. Nope. That's not right either. 5 times 2 is 10. My denominator stays the same with a 3. 10/3. That's the same as 10/3. So yes, this is a yes. 10 times 1 is 10. My denominator stays the 3. 10/3 is the same as 10/3. That's a yes too. Okay? Last example. You're going to see something like this. It reads, Celia puts 3/5 of a pound of nuts into each of 4 bags. Sorry, this is hard to read. What expression can be used to find the total amount of nuts she uses? Drag an expression into each box to complete the sentence. Okay, so I'm just trying to think about this in my mind. She has 3/5 of a pound of nuts into 4 bags each. Okay, I'm just going to write this down. So 3/5. And that's in 4 bags each. So I'm multiplying it by 4. Okay? So this says the addition expression is, so what would this be as repeated addition? It's going to be 3/5 4 times. So 3/5 plus 3/5 plus 3/5 plus 3/5. So I'm going to look and see if that's there. Yep, here it is. I drag and drop that there. Then it says, can find the total number of pounds of nuts Celia uses. This addition expression is equivalent to the multiplication expression. Okay, I know my multiplication expression is supposed to be something like this. They flip-flopped it and they have 4 times 3/5, but I know I can flip-flop numbers in a multiplication problem. So it's going to be 4 times 3/5, which is going to go here. And then it says another way to write the multiplication expression is, so, what are my other options here? Let's solve this so that we can think about what our other option would be. Because I need to find a multiplication expression that's going to equal the same thing as this. So when I solve for this, I do the whole number times the numerator. 4 times 3 is 12, and it stays over 5. So the other multiplication expression needs to be equal to 12/5. This one says 4 times 1/5. So 4 times 1 is 4 over 5. No, it's not the same. This says 5 times 1/4. 5 times 1 is 5 over 4. No, that's not the same either. How about this one? 5 times 3/4. 5 times 3 is 15 over 4. Nope, not quite. How about 12 times 1/5? I think this might be right because I know my answer is supposed to be 12/5. And if you have 1/5 12 times, that one equals 12/5 as well. So this would drag and drop into here. 12 times 1/5. Okay? All right, guys, good luck on your lesson 23 comprehension check. You got this.